Hello everyone. We now look into fourth variant of product mix problem in Python for minimizing the idle time in production. This has been viewed in form of assembly line balancing with 3 workstations for producing 2 radio products high-AF1 and high-AF2. Pulp and Pandas packages on operations research solver and data manipulation in Python are loaded. Along with the packages, data is also loaded. The total time in a shift is 480 minutes for each workstation denoted by toTime parameter. The processing time for the 2 products on each workstation is enumerated under Prod's time list. There is a planned downtime for maintenance and the respective workstations have certain proportion of time allotted for the same under main list. An enumerated list Prods is defined for 2 products on 3 workstations for linear programming model. For easing data slicing in the model, we employ a data frame for processing time and maintenance proportion under ProdStimid and maindef. We create a class ProdMixMin idle time for minimizing idle time for product mix problem. Then initialize the class with the method and feed the data and data frames to it instantly. Next, we define the problem self.prob for minimizing the idle time. The problem is a case of mixed integer problem with integer variables self.x for product produced and continuous variables self.s for idle time in 3 workstations. After declaring the variables, objective function is defined. The objective function is prepared by summing up idle time on all workstations self.s. The constraint is defined for each workstation such that idle time self.s added with summation of processing time of all products on the workstation is equal to total available time in a shift. The total available time in a shift is computed by deducting proportion of maintenance time from toTime parameter, which is 480 minutes. The formulated problem is then invoked for solving with solve method. Please note we also write a .lp file, which is a good way of checking accuracy of model with data. Along with it we get the status, objective value and variables value for the problem. The formulated model is solved by invoking the solver. The optimal product mix requires producing 51 units of radio high-AF1 and 30 units of radio high-AF2. The idle time for the 3 workstations 1, 2 and 3 are 2.8 and 32.4 minutes, which totals to 37.19 minutes overall. The code for the problem in this tutorial and previous tutorial are shared publicly on GitHub. The links are under the respective videos. Thank you for watching the video and please subscribe to the channel.